Hi guys, so I just want to show you an example of how to create a model using a trig function. In this particular example, what we're looking at are the average maximum temperatures for a particular location over various different months. And we want to model that using a sine function. The first step in any question like this is to draw a graph of your data. So I've done that here. So if we treat each month as a number, so we would make January 1 and February 2 and so on, then we can graph that, and I'm going to call that variable t for time. So the month is t, and then we're going to use big T to represent the temperature. So if I graph that and then look at the graph, we can see that this is following that sort of trigonometric pattern that you see in a sine or a cosine wave. And then we can start to pull out some different numbers to go into our model. So what we might do when we look at this is we'd go, okay, well, the period, the time it takes for the pattern to repeat itself should be 12 months. So you can see it started up high, and after 12 months it's gotten back up high again. And typically with any sort of problem involving variation over a year, you would expect the period to be 12 months. What this means is we can work out B by doing 2 pi divided by the period, which was 12, and that gives us pi over 6 for our value of B. We can then work out the amplitude. So the amplitude of the sine model is just basically halfway from the highest possible value to the smallest possible value. So max minus min divided by 2, which in this case gets us 6.5. So that gives us our value for A in the model. So we've got A and B now. We can also get the principal axes. So that's like the line that goes down the middle of all of our data. In this case, that's like the average or the halfway point between the highest and the lowest values. So max plus min divided by 2, which gives us 21.5. So that means that our D value is 21.5. And if we graph that on, you can see that's roughly where our principal axis is. So the last part of the picture is C. C is the trickiest one to get. Now in this case, because we're looking for a sine model, we're looking for where the graph is starting on the principal axis and heading upwards, because that's what the sine function does. The sine function starts on the principal axis and goes up. So this point here wouldn't count. That's on the principal axis, but the model is going down. So we would actually use this value here to get our C value, and we just read that straight off of the x-axis as 10. So we set C to 10, and that basically offsets the model by 10, so it moves it back to the start because the sine function should be starting at the principal axis and traveling up. So when we put that all into our model, our standard model is y equals a sine and then b multiplied by x take c and then plus d on the end. In this case, our y value is big T. A is 6.5, b is pi over 6. Our x is actually what we've called t, so I'm going to change that to a t minus 10, which was our c value, and then add on 21.5. And this equation here would give us our model for temperature. Okay, I hope that makes sense. Thank you for watching.